Welcome to part 2 in this series of videos where I'll be looking at cascading grids in a Blazor application. In this video, we'll look at the database. Before we look at the database, a quick reminder of what our finished application should look like. It's to calculate the area of walls in rooms, and we have to start with a project, and then we have a series of grids. A grid for rooms, a grid for walls, and a grid for deductions. Selecting a project will allow the user to select a room. Selecting a room will show the walls for that room, and selecting a wall will show any deductions that need to be subtracted from the area of that wall to arrive at a net area. And that gives us a total net area of the whole room. So the data structure is project, rooms, walls, and deductions. The data we need to record is, from a database perspective, pretty simple. Just a few tables linked by one-to-many relationships, as shown here. We'll have a project which can link to many rooms. Rooms can link to very many walls, and walls can link to many deductions. We'll be taking a database first approach in this project. This means that we will create the database outside Visual Studio and the C# code. The tool I have selected to do this is DB Browser for SQLite. Once we have added the database and added the tables, we'll then return to Visual Studio to include the database in the project. The tasks we have in front of us are therefore to install DB Browser for SQLite. Using DB Browser for SQLite, we'll then add the database and tables. Having done that, we'll return to the C# project and add the connection string to link the database to the project, and then add data models for the project. Lastly, we'll carry out a spot of housekeeping to get rid of some redundant code that comes with the predefined template for a Blazor server application. So let's get started and install the DB Browser for SQLite. To install DB Browser for SQLite, go to the web address. I'll put it in the description. It's SQLitebrowser.org, and then select Download. We'll need the standard installer for 64-bit Windows, so select that and either save or open. I'm going to open it and I'll come back when it has opened. Now we simply follow the setup wizard. So click Next, accept the license, click Next. You might want to create a desktop or program shortcut. I wouldn't bother with the SQL Cipher shortcuts. Click Next, accept the default for location, and install. And then finish. We will open DB Browser for SQLite shortly, but before we do that, we need to know the location to save our database. And to do that, we need to go back into our C# project. So if you haven't already got it open, open the project, and we need to go to the Solution Explorer and right-click the data folder, because that's where we want to save the database. So right-click and copy full path. That will copy it to the clipboard. Now we need to start DB Browser for SQLite. So we need to create a new database. So we click the New Database button and we paste into here the path that we've just copied from the data folder, and press return. And it seems to be important that you need to press return there, otherwise you won't end up in this folder. Then we need to give the database a name. I'm going to call mine Wall Area Calc, and then save it. We aren't going to edit any tables here for the moment, so we can cancel that. Rather than entering the database tables using the Create Table interface, I'm going to use a script to add the tables. If this tab called Execute SQL is not visible, click on View and then Execute SQL. Sometimes it's visible, sometimes it isn't. But I'm just going to set it back to visible, select that browser, and then I'm going to copy and paste the script that I want into here. I'll put a link in the description to where you can find this script, but it'll save a lot of time. So paste it in, and I'll briefly explain what we've got here. First of all, just as a precaution, I'm going to drop the table if it exists. So I've got 4 tables: the project, the room, the wall, and the deductions. The first one I'm going to create is project, and it's got 3 fields. A project ID, which is an integer. It's going to be the primary key, and it's going to auto increment. And that means that as we add records, it'll just keep on adding the ID and it'll increment it automatically. It saves us the task of doing that. I've got a text field for user email, which at this stage we won't really need, but I'm putting it in there just in case I decide to publish this to something like Azure, and I want to use the Azure B2C authentication. But that's for another day. Then we've got the project name is text. I'm not going to allow nulls, and I'm going to make sure it's unique. So we can't have 2 projects called whatever. Next table is room. Again, we follow the same pattern. So we've got the room ID, which is an integer, and it's going to auto increment. But then we've got the link to the project ID. And that's going to be an integer, and that's not going to be allowed to be null. So when you add a room, the project ID must go with it. And then we're going to give it a room name. So it could be bathroom 1 or sitting room or something like that. And this is the important part. It's got a foreign key, and the foreign key is project ID. So that's linking the room table back to the project. And what I want to do here is add this reference to the project ID on delete cascade. This is to allow me to delete a project, and it will then delete all the rooms associated with that project. It goes further than that, in that if we've got walls in the room and deductions for the walls, if we delete a project, it will delete all child records. Right, so for the wall, it's fairly straightforward. We've got the wall ID, again, auto-incrementing, a room, which is the foreign key, and then we've got a room type and a type name. I'll come on to those later. And then we've got the lengths and height of the wall. I'm also including the wall square meter here. That is not strictly necessary, and database aficionados will doubt whether or will question whether I need that. In theory, I don't. I should be able to calculate it every time I want it, but it's going to make life easier if we just record it. Then I've got the foreign key to the room, and I'm going to allow this delete cascade. And lastly, the deductions, which follows exactly the same pattern. So that's the script, and now I simply run it. And it's finished without errors, so we should be good to go. I'll just minimize that. Actually, there might be one thing that I've forgotten to do here. I want to make sure I write the changes. I think they would have been written anyway, but just to make sure, I click Write Changes. Now I'll minimize it. If I open the data folder, we should then see our wall area calc database in here. We can set one of the properties of the database so that when we publish the application, the database is included with the package. So we right-click on the database and select Properties. And up here we've got Build Action, None, and we want that to change to content and copy to output directory. We've got do not copy at the moment, and we want to copy if newer. These settings can be changed later if a different behavior is required, but selecting this to start with will ensure that the database is published as part of the project. So I can close that now. Next, we need to define the connection string. And the connection string is what links our project to the database. Although it's located there, the project itself doesn't know about it. And we need to add a connection string to app settings. So if we open app settings, we need to add this section here. I'll put a comma there, and then we can paste this in. So it says connection strings, and that is called default, and it's going to be data wool area calc, which is the name of the database, and it happens to be version 3. So I'll save that. And now we can move on to what are called models. The models are classes, and we have one model class per table. So the first one we're going to create is a class for the project. So right click here, select add, and it's a new we can just select class, and I'm just going to call this project.cs and add. The code for this I'll put a link to in the description, but I'm simply going to copy and paste into here the information we need for that, or the code we need for that. And I'm going to replace all of it with this. So this follows or mirrors the table definitions that we added to the SQLite database. So I'm using, wrong word, but I'm adding using system component model .data annotations to allow us to give error messages. Then I've got the namespace of our project, and the class is called project. So the required here says that the next field has to be present, and it's a public integer project ID, which is the same as the ID for the project that we set up in the database. And this is the error message that we use for the user email. So we've got required, and the error message is user email is required, and I'm forcing it to be of type email address, and then we've got an error message if they forget to put it in the correct format, and then I've got a string length of maximum of 50. So it's a string, it's a user mail, and I'm setting it to an empty string, and similarly for project name, I'm setting it to an empty string. And again, I've got certain requirements and error messages here. So that's the first one. So I'll save that. The next one we want to add is a room. And again, to save time, I'm going to copy and paste. Now for this one, I haven't put the data annotations or the error messages in here, simply because I'm lazy. But if you wanted to put in error messages, you could follow the examples that I had on the project model class. So again, it mirrors exactly what we've got in the database. I'll save that as well. And now I'll add wall. The code for wall is this. There are more fields here, or more columns. The one that is a little bit different is that the wall square meter, which is the total area, I've set to a decimal rather than integer, and I'm setting it to 0. All the others I'm setting to 0 or empty strings. I'll save that. And lastly, we want a class for the deductions. And I'll paste in the code we want for that. Again, it follows the database structure. So I'll save that. So that is basically setting up the database in the SQL database and adding the models to the project. Now, I want to do a little bit of housekeeping, and we won't need a number of these items. We don't need the weather forecast, so I'm going to delete that. And I don't need the weather forecast service either. There are some pages we don't need. We don't need the counter page. And we don't need the fetch data page either. And under shared, we don't need this survey prompt. On the index page, we don't need the survey prompt, so let's get rid of that. And on the menu page, again, nav menu, we don't need this link to the counter, so I'll comment that out. And we don't need this one to the fetch data either. And I think we'll just change that to say wall area calculator. I think that's all for the menu. And one last change to program.cs. We want to get rid of that because we've got rid of the weather forecast. And I don't think we need that using statement at the top either. So with those changes, we ought to just check that it's working. So I'll save everything and run it. Well, it's always a relief when it works, and there we have it, it's working. Now we've added the database, we've added the tables, and we've added the models, but of course we haven't got a method of adding, editing, or deleting any records. And that's going to be the subject for the next video. I'll put links where necessary in the description, and we'll move on in the next video to adding the methods for adding, editing, and deleting records. Thank you very much for watching this video.